So welcome guys to our YouTube video, and in this YouTube video we will be learning how to solve word problems involving fractions and percentages. To help us with this, our textbook of reference will be the New General Mathematics for Junior Secondary Schools, Book 1, and this book is referenced in our description using the Harvard referencing style. So let's get right into it. Now, to help us understand how to solve word problems, we will be looking at several examples and we will see how to solve them. Now, the first example that we have here is this one, which says, express 2 minutes and 15 seconds as a fraction of 7 minutes and 30 seconds. So how do we solve this? So let's move to our whiteboard. Okay. Now, just write this solution. Remember, the question says express 2 minutes and 15 seconds as a fraction of 7 minutes and 30 seconds. So how do we solve this? First, what we want to do is to express these two durations of time in 1 unit. Now I'm going to choose to express it in seconds. Okay, so I'm going to express in seconds. Now, how do we express this in seconds? First, we must remember that 1 minute is equal to 60 seconds, right? So with this in mind, we take the first duration of time, just 2 minutes and 15 seconds. Okay, so first of all, we have 2 minutes in seconds. So how do we express 2 minutes? We have 2 here in minutes, so how do we express 2 minutes in seconds? Now, if you know that 1 minute is equal to 60 seconds, therefore 2 minutes is equal to 60 seconds times 2, or 2 times 60 seconds, which is equal to 120 seconds. And then 2 minutes and 15 seconds is equal to 120 seconds plus 15 seconds, which is equal to 135 seconds. The same thing we will do with 7 minutes and 30 seconds. Okay, 7 minutes is equal to 7 times 60 seconds, which is equal to 420 seconds. Therefore, 7 minutes and 30 seconds is equal to 420 seconds plus 30 seconds, which is equal to 450 seconds. Okay, so now that we have 2 minutes and 15 seconds is equal to 135 seconds, and 7 minutes and 30 seconds is equal to 450 seconds. To express, just going to write out the question again. Express 2 minutes and 15 seconds as a fraction of 7 minutes and 30 seconds. Now, to do this, what we just need to do is to say, because this we know is 135 seconds, right? And this we know is 450 seconds. So the solution will simply be 135 seconds divided by 450 seconds. Okay, so I'm just going to draw a neat line here. Okay, now this is equal to 135 over 450. Now, how do we express this in its lowest terms? Now remember that a common factor between 135 and 450 is 5. So we start by dividing with 5. 450 divided by 5 is 90. 135 divided by 5 is 27. And then the next common factor is 9. And 9 in 27 is 3. And 9 in 90 is 10. So this expressed in its lowest terms gives us 3/10, which is the solution. Okay. Now we should also note that this question might come in this form, which says, what fraction of 7 minutes and 30 seconds is 2 minutes and 15 seconds. So if we see the question in this form, just know that we applied the same method to solve it. Okay, so now let's move to the next example. Okay, now this question says express 25 cents as a percentage of $1. Okay, express 25 cents as a percentage of $1. So how do we solve this? Let's get back to our whiteboard. Okay, so we're just going to clear this to make space for our next question. Okay, so it says express 25 cents as a percentage of $1. Okay, so how do we do this? First of all, we need to express 25 cents as a fraction of $1. After expressing 25 cents as a fraction of $1, we then express that fraction as a percentage. Okay, but the first thing we need to do is to express both quantities in the same units, just like we did with the previous example. Now, we know that 100 cents is equal to $1, right? So if 100 cents is equal to $1, 25 cents will be equal to 25 over $100, which when expressed in its lowest terms gives 1/4. Okay, now this is just 1/2 of the work, right? Remember, we still need to express 25 cents as a fraction of $1. So what do? We simply say 1/4 divided by 1. Okay, and then 1/4 divided by 1, or any number divided by 1, is equal to that same number. So we have this as 1/4. Now to express this as a percentage, we say 1/4 times 100%. Okay, which gives us 25%. Now we'll move to the next question. Let's go back to our slides. Alright, so the third example says a fruit grower uses 1/3 of his land for bananas, 3/8 for pineapples, 1/6 for mangoes, and the remainder for oranges. What fraction of his land is used for oranges? So how do we solve this? So the first thing to do is to write out all the information that we have. Okay, so the first information that we have is it uses 1/3 for bananas. Okay, so say 1/3. For bananas, and 3/8 for pineapples. And 1/6 for mangoes. Okay, so what remainder is left for oranges? Alright, so the first thing we must keep in mind is that 1 represents the whole fraction, or 1 represents the whole land in this case, or the fraction of the whole land in this case. So if we add all these 3 fractions together for bananas, pineapples, and mangoes, the remainder will be what will be left for oranges. Okay, so how do we do this? Okay, so sum of 1/3, 3/8, and 1/6. Now the LCM of 3, 8, and 6 is 24. 24 over 3 gives 8. 24/8 gives 3, and 3 times 3 gives 9 here. And 24/6 gives 4. 4 times 4 gives 4 here. Okay, so if we add 8, 9, and 4, we get 21/24, which when expressed in its lowest terms, 3 goes here 7, 3 goes here 8, gives us 7/8. Okay, so we have that 7/8 is used for bananas, pineapples, and mangoes. So what is the remainder that will be left for oranges? Now to get the remainder, we simply say 1, which is the whole fraction of the land, minus 7/8. Okay, now just like we did before, we can find the LCM of 1 and 8. This gives us 8 here, and then 8/1 is 8. 8 times 1 is 8, minus 7. It gives us 1/8. Okay, now a quicker way to solve this, if we have something like this to solve, where we have 1 minus or plus any fraction, all we just need to do is to add the denominator with the numerator. I'm sorry, in this case it is subtract, so we subtract the numerator from the denominator and then put the value that we get over the denominator. For example, this is 1 minus 7/8. All we simply need to do is to say 8, which is the denominator, minus 7 gives us 1, and then we say 1/8. Okay, same thing if we had 1 minus 3/4, we simply say 4 minus 3, it gives us 1. Then the answer is 1/4. we had 1 plus 5 over 6. We simply say 6 plus 5. It gives us 11. And then we'll simply say the answer is 11 over 6. So that's just a quick way to solve this kind of fractions. So now we have our final solution here, final answer here to be 1 over 8. So let's look at the next question. Okay, so this question says 1 over 5 of the timetable for a class is given to English and 1 over 8 is given to mathematics. What fraction is left for other subjects? Okay, so this is similar to the question we just solved. So I'm just going to clear the whiteboard here to make space for the next question. Okay, so I'm just going to write solution. Now we have that 1 over 5 is given to English and 1 over 8 for mathematics. Okay, so how do we solve this? What fraction is left for other subjects? So just like we did before, remember 1 represents the entire fraction, okay, of the timetable. So we simply say 1 minus 1 over 5 plus 1 over 8. This is the solution. So how do we do this? Remember, in our order of operations, we solve what is in the bracket first. Okay? Now in solving this, this is what we have. So this is 1 minus 8 plus 5 over 40, which gives us 1 minus 13 over 14, which gives us 27 over 14. So this is our final answer. Okay, so to the next question. By how much is the sum of 2 whole number 4 over 5 and 4 whole number 1 over 2 less than 8 whole number 1 over 10? So this is a really simple interpretation, and the interpretation of this is, okay, I'm going to draw the line here. Okay, so the interpretation of this is 8 whole number 1 over 10 minus 2 whole number 4 over 5 plus 4 whole number 1 over 2. Okay, so how do we solve this? Now, once you express all the mixed numbers as single fractions, so 8 whole number 1 over 10 expressed as a single fraction is 81 over 10, and 2 whole number 4 over 5 expressed as a single fraction is 14 over 5. 4 whole number 1 over 2 expressed as a single fraction is 9 over 2. Okay. So remember, in our order of operations, of course, we solve what's in the bracket first. So the LCM here is 10, and this is what? 10 over 5, that's 2. 2 times 14, that's 28. 10 over 2, that's 5. 5 times 9 is 45. Okay. So we have that this is 81 over 10 minus 73 over 10, and this gives us 8 over 10, or 4 over 5 expressed in its lowest terms. So this is the solution. So we'll move to the next question. Okay, now this says LP records turn round 33 whole number 1 over 3 times every minute. If one side of an LP plays for 24 minutes, how many times does it turn round? Okay, so now this is pretty easy. So to solve this, okay, we just clear this, right? Let's make space. Okay, now the question says the record turns 33 whole number 1 over 3 times in 1 minute. Therefore, in 24 minutes, it turns 24 times 33 1 over 3 times. Okay. So how do we do this? Now, if we express if we express 33 over 33 whole number 1 over 3 and as a single fraction, we get 100 over 3. So multiply 100 over 3 by 24. So we did this 3 here 1 and 3 here 8. So this gives us 800. So the answer is 800 times. Pretty easy, right? So we just clear our canvas for the next question. Okay, so the next question is, now this question says one lecture at an evening course lasts for 1.5 hours. If the course lasts for 30 hours altogether, how many lectures are there? Now, all we simply need to do is to say 30 divided by 1.5. This will give us the number of lectures that exist or that are there. So we'll go back to our whiteboard to see how we can do this. So, solution is, okay, we know that one lecture lasts for 1.5 hours. Okay. So whole lesson lasts for 30 hours. So how many lectures were there? Now we simply say 30 divided by 1.5. Okay. Now 30 divided by 1.5 is the same thing as 30 divided by 3 over 2. That's when 1.5 is changed to a single fraction. This is equal to 30 times 2 over 3, which is equal to 3 goes here 1, here it's 10, and 10 times 2 is 20. So this is 20 lectures. final answer is 20 lectures. So on to the next question. Okay, so some shop sold goods are sold for 2/5 of their original price. What will the selling price be of a t-shirt originally costing $850? So how do we do this? So remember, they're telling us that the goods are sold for 2/5 of the original price, meaning that the t-shirts will cost 2/5 of the original price, which is $850. So to do this, we simply multiply 2/5 times 850. Okay, and this gives us 5 here, 1, 5 in 850 is 170. So 2 times 170 is 314. So the answer is $340. Now, if you're having problems dividing 850 by 5, this is how you do it. Now, first you say 5 goes in 8 to give what? 1, right? Because 5 times 1 is 5. But then it gives a remainder of 3. So we append this 3. So we append the 3 to 5 here. So that gives us 35. And 35 divided by 5 gives us 7. So we say the answer is 170. That's how I'll go 170 here. And then 170 times 2 is 314. So that's the solution. So we'll move to the next question. So this question says, in a school, 9/10 of the students play sports. 2/3 of this fraction of these students play football. So what fraction of the students play football? Now this is very easy. All we just need to do here is to multiply 2/3 by 9/10. Okay. Okay. 2/3 times 9/10. Okay, so 3 goes here, 1, 3 goes here, 3, 3 here, 1, 2 here, 5. So this gives us 3/5. Now this is the solution. Okay, so to the next question. So this question says, it takes one whole number 3/4 meter of cloth to make a skirt. How many skirts can be made from 10 whole number 1/2 meters of cloth? Okay, so all we just need to do here is to divide this by this. Okay, that's 10 whole number 1/2 divided by 1/3. Alright, so let's also a whiteboard to get the solution. Alright, so we're just going to clear this canvas. Okay, so you have one skirt is made with then 10.5 meters makes 9 squares. Okay, so the answer is simply doing this 10.5 divided by 1 whole number 3/4. So we convert this to a single fraction. 2 times 10, that's 20. 20 plus 1, that's 21/2 times, okay, I'm still going to put divided. Okay, so we'll take it step by step. Divided by 7/4. This is equal to 21/2 times 4/7. And then 7 goes here 1, 7 goes here 3, 2 goes here 1, 2 goes here 2. So the answer is 6. Or 6 squares. Okay. Now the next question says, a farmer uses 9/16 of a field to grow cassava, or for growing cassava. He uses 2/7 of the remainder for growing corn. What fraction of the field is used for growing corn? Okay, so first of all, we need to find the remainder that is left after growing cassava, and then we'll find out what is 2/7 of the remainder, which will give us what is used for growing corn. Okay. Okay, so 9/16 of the land for cassava, and then the remainder with 2/7 of the remainder for corn. Now remember, 1 represents the whole fraction of the land. Okay, so if 9/16 is used for growing cassava, then the remainder will be 1 minus 9/16, which is equal to 7/16. Okay, and we are told that 2/7 of the remainder is used for growing corn. So if the remainder is equal to 7/16, then 2/7 of the remainder is 2/7 times 7/16, which is equal to 7 goes here 1, 7 goes here 1, 2 here 1, 2 here 8, which is equal to 1/8. So therefore, the fraction of the land which is used for growing corn is 1/8. Okay, so to the next question. Now this one says the ball bounces 3/5 of the height from which it falls. If it falls from a height of 1 meter, how high will it rise after the second bounce? Okay, now let's analyze this question. So it falls from a height of 1 meter, right? So we know the first bounce will be equal to 3/5 times 1 meter, which is equal to 3/5 meters. So the second bounce, after it goes up a height of 3/5 meters, will be 3/5 times 3/5 meters, which is 9/25 meters. So this is the solution. Okay, so on to the next example. Okay, so in an exam, a student scored 60 marks out of a possible 80. What percentage is this? So this is very simple and straightforward. To express this just says express 60 as a percentage of 80. So what we do here is we simply say this is pretty easy. So we just say 60/80 times 100%. Alright. So 60/80 times 100%. How do we do this? Now, first we can cancel the zeros here. Then we say 2 goes in here to give us 4, 2 goes in here to give us 3. 2 goes in here to give us 2, 2 goes in here to give us 15, 2 goes here 1, 2 goes here 25. So we're left with 3 times 25, which is 75%. Okay. Next one. 3 girls are absent from a class of 25. What percentage of the class is absent? Pretty easy as well. Okay. All we need to do here is to say 3/25 times 100%. 3/25 times 100%. So 5 goes here 5, 5 goes here 20, 5 goes here 1, 5 goes here 4. So this is 12%. That's the answer. Okay, and then the next question. Okay, so 26 centimeters of wood is cut off a board 130 centimeters long. What percentage has been cut off? Okay. So just clear the board here to make space. Alright, so I'm just gonna write solution. Okay. So 26 centimeters cut off from 130 centimeters of wood. Percentage cut off. Okay, so we'll simply say 26/130 times 100%. Okay, now this gives us 0, cancel 0 here. 13 goes here 1, 13 goes here 2. So the answer is 2 times 10, that's 20%. Okay, the next question. In a box of 200 oranges, 18 are bad. What percentage is bad and what percentage is good? So I have 2 questions here. Okay, how do we solve this? Okay, just draw our new line here. Okay, from the we have 200 oranges. Okay, 18 are bad. So we're to find the percentage of bad oranges and to find the percentage of good oranges. Okay, so percentage of bad oranges is equal to 18 over 200 times 100%. Okay, so 0 cancels 0 here, 2 here, 1, this is 9, so this gives us 9%. Now, remember, 100% represents the whole percentage. Of oranges. So if you have that 9% are bad, it means that percentage of good oranges is 100% minus 9%, which is equal to 91%. So this is the answer. Okay, so we'll look at the next question. Okay, a piece of elastic is 48 centimeters long. It is stretched to a length of 60 centimeters. What is the increase in length and what percentage of the original length is the increase? Okay, so let's go to our whiteboard to get the solution. So we just clear this. Okay, so we have original length is equal to 48 centimeters. And the stretched length is what? 60 centimeters. So to get the percentage that is stretched, we simply say 60 centimeters minus 48 centimeters. That gives us what? Gives us 12 centimeters. Alright, so the percentage stretched is equal to 12 centimeters over the initial original length, which is 48 centimeters times 100%. So 12 goes here 1, 12 goes here 4, 4 goes here 1, 4 here 25. So the solution is 25%. Okay. Okay, so this question says, a motorist buys a 5-liter can of oil to maintain her car. She used 800 milliliters. What percentage of oil has she used and what percentage remains? Okay, so let's solve this. So to solve this, we write out the details that we were given in the question. Okay. So we know that she buys 5 liters of oil, and then she uses 800 800 milliliters. Okay. What percentage is used? So the question says, what percentage is used and what percentage remains? And what percentage remains? Okay, so now let's express 800 milliliters in liters. So 800 milliliters is equal to 800 times 1 over 1000 liters. This gives us 0 cancels 0 here. This gives us 8 over 10 liters, which is equal to 4 over 5 liters. Okay, so we know that 4 over 5 liters is used. Now, to get the percentage that is used, we will say quantity used over original quantity times 100%. Now, quantity used is 4 over 5 divided by the original quantity, which is 5 times 100%. Okay, so this is 4 over 5 times 1 over 5 times 100%. So 5 goes here 1, 5 goes here 20, 5 goes here 1, 5 goes here 4. So 4 times 4 is 16, so this gives 16%. Okay, now so we have that 16% represents the quantity that is used, or the percentage of oil that is used. So if 16% is used, we have that 100% minus 16% remains, which is equal to 100 minus 16, that is 84%. So 84% is what remains. So these are the answers: 16% and 84%. Okay, so on to the next question. So this question says the distance between two villages is 8 kilometers. A student walks from one village to the other. He walks most of the way but runs the last 480 meters. What percentage of the journey did he run? Okay, so let's write out the details in our whiteboard. So the distance between the two villages, so I'm going to say total equals 8 kilometers, and then distance run is 480 meters. So the question says, what percentage did he run? Okay, so now to do this, we have to express both quantities in the same units. So I'm just going to choose to express 8 kilometers in meters, which is equal to 8,000 meters. That is 8 times 1,000 meters. Okay. Now find the percentage that he ran, what we do is we say 480 divided by 8,000, or over 8,000, times 100%. So 0 cancels 0 here, 0 cancels 0 here, 8 goes here 1, 8 goes here 6. So this is equal to 6%. So we say that he ran a distance of 6%. So this is the answer. And now to the next question. A man bought a second-hand car for $700,000. He sold it 3 years later for $560,000. What percentage of money did he lose? Okay, so we're just going to pray this. Okay, so write out the details, just like we did with the first one. We bought the car at $700,000. He sold at $560,000. So what did he lose? So his loss is equal to $700,000 minus $560,000, which is equal to $140,000. And then the percentage lost is equal to 140,000 divided by 700,000 times 100%. And this is equal to 20%. So this is the answer. Now the next example says, during a physics lesson lasting 1 hour, it took 9 minutes to set up and clear away apparatus. What percentage of lesson time was used in this way? Okay, meaning that what percentage of lesson time was used to clear away the apparatus? Alright, so let's go to our whiteboard. We're just going to draw a neat line here. Okay, so total duration is equal to 1 hour, and time spent clearing apparatus is 9 minutes. Okay, so percentage of time spent doing this will be 9 minutes over 1 hour times 100%. But remember, we have to express both quantities in the same minutes. So I'm going to choose to express 9 minutes in hours. Now remember, 1 hour is equal to 60 minutes. Okay. So 9 minutes is equal to 9 over 60 hour. Alright. So the percentage of time spent is equal to 9 over 60 divided by 1 times 100%. Okay, so this is equal to 9/60 times 100%. 0 cancel 0 here, 2 here, 3, 2 here, 5, 3 here, 1, 3 here, 3. So this is equal to 15%. Okay, so if this was a bit confusing, remember we could also choose to work with minutes instead of working with hours. So if we decided to work with minutes, we'd simply express 1 hour in minutes, which is 60 minutes, right? And then we simply say percentage time spent would be equal to what, 9/60 times 100%, and we get the same thing as 15% as before. Okay. So the next question, which is the last, is a cake has a mass of 2.5 kilograms. It contains 275 grams of fruit. What percentage of fruit is there in the cake? Okay, so how do we solve this? Let's go back to our whiteboard. So we're just going to clear this out. And clear this to make space. So we have that total mass of cake is 2.5 kilograms, and mass of fruit and cake is 275 grams. Okay, so remember, okay, and the question says what percentage of fruits is in the cake. Okay, so remember we have to express both. We have to express both quantities in the same unit. Okay, so 2.5 kilograms is equal to 25 kilograms over 10, okay, which is equal to, when you express it in its lowest terms, this is equal to 5/2 kilograms, okay, and 5/2 kilograms, right? Now, to express this in grams, I'm going to choose to express it in grams. 5/2 kilograms is equal to 5/2 times 1,000 grams. Okay. So 2 here, 1, 2 here, 500. Okay, and 5 times 500 is 2,500. So this is 2,500 grams. So we have to find the percentage of fruits in the cake. We say the mass of fruits in cake which is 275 divided by the total mass of cake, which is 500 grams, times 100%. So 5 goes in 275. Remember, 5 in 27 gives 5, right? The remainder of 2, and 5 in 25 gives 5. Okay. Now 5 in 2500 is 500. 5 in 55 is 11. 5 in 500 is 100. And 100, we cancel 100 here. So we're left with 11. So we're left with 11%. So this is the answer. Alright guys, so that's the end of the lesson here on word problems in percentages and fractions. I hope you learned a lot. So thanks for watching.